Hello friends, subscribers and new viewers of this channel, and welcome to Machine Learning and AI Tutorials. We are continuing the tradition and well-established practice of this channel of explaining how to install AI models on both Linux Ubuntu and Windows computers. In that spirit, in this video tutorial, we are going to explain how to install the newest NVIDIA large language model called Llama-3.1-Nemotron-Nano-8B-v1 on a Linux Ubuntu computer. In our previous tutorial, we explained how to install this model on a Windows computer, and a link will be given in the description below. Okay, let's start. First of all, let's explain why is this model so special. Well, as the name suggests, this model is derived or trained from Llama 3.1 model. Namely, Llama 3.1 model is arguably one of the most popular open source, or better to say, open weight models out there. However, the issue with Llama 3.1 is that it is a little bit outdated, taking into account that it's being published somewhere around mid of 2024. Now it's March 2025 and we need better and more powerful models, or we need models that have the same number of parameters, however, that are more powerful and that can be executed on local computers. Llama 3.1 Nemotron-Nano-8B-v1 is a good step toward that direction. That is, good step toward upgrading and improving Llama 3.1. And let's immediately summarize this model. First of all, a very interesting thing over here is that this model is released in PF16 precision. Now, it's not being quantized still, and in order to install this model, we have to follow the Hugging Face approach. That is, we need to download the Hugging Face files, and then we need to write a simple Python script shown over here that will run this model. However, in order to run this Python script, you need to install a number of things. You need to install CUDA, you need to install Pytorch, you need to verify that CUDA and Pytorch compilers are completely matching each other, and then you need to install additional libraries. All this needs to be done in a separate Python virtual environment. And in this tutorial, we will do all these steps. That is, we will explain how to install and run this model on a local Linux Ubuntu machine. Also, before we start with explanations, let's just explain several things. First of all, this model is post-trained for reasoning, human chat preferences, and tasks such as RAG and tool calling. That is, RAG and tool callings should be the main application of this model. Consequently, if you developed your own RAG or tool calling system, you can simply replace Llama with this updated model. Another important thing is that this model fits on a single RTX GPU and can be used locally. And the model supports a context length of 128K. In our case, we will be running this model on NVIDIA 3090 GPU with 24GB of VRAM. I kind of expect that this model will also run on lower end GPUs. I'm not sure how much RAM will you need to run this model. However, I was able to run it successfully on NVIDIA 3090 GPU with 24GB of VRAM. Okay, let's start with explanations. First of all, you have to have NVIDIA CUDA Toolkit on your system. In particular, I tested this model by using NVIDIA CUDA Toolkit 12.6. To install NVIDIA CUDA Toolkit, if you don't have it, search NVIDIA CUDA Toolkit 12.6, click here, then select your operating system, Linux. Make sure that you select this version, then select Ubuntu. Select Ubuntu version, in my case it's 24.04, and the easiest approach is to install by using this option, and these commands will be generated. After that, you also need to basically, after actually executing these commands, you also need to set the NVCC compilers and all the binaries of NVIDIA CUDA Toolkit inside of the system path. In fact, I created a separate video tutorial on how to properly install NVIDIA CUDA Toolkit on a Linux Ubuntu system, and the link will be given in the description below. Of course, then you also need Python. However, if you have Linux Ubuntu, either version, you will most likely have Python installed on your system. Okay, let's start with installation. First of all, click here, then search for terminal, then over here, I'm going to resize the screen such that you can see what I'm typing, and at the same time, you can see the commands over here. Okay, so what do we need to do first? We need to run these two commands. First of all, we need to update, enter your password. This might take a while. And after this command, we need to execute this command that will actually upgrade all the packages. And press enter and press Y. Next, let's verify our Linux Ubuntu distribution. You can do it like this. And then let's verify that we have NVIDIA CUDA compilers. To do that, you need to execute this command. And if you have installed NVIDIA CUDA Toolkit, after running this command, you should see something like this with your current CUDA version. Next, let's verify that Python exists on our system. We can do it like this, and you can see that there is an error. Does this mean that Python is or not installed on my system? Well, instead of running this, you need to run actually this, and you should see your current Python version. Remember these two numbers since they will be very important. Next, let's go to the home drive and let's create a workspace folder. Let's call this folder test10 and let's navigate to this folder, and inside of this folder let's create the Python virtual environment. First of all, we need to install the command for creating the Python virtual environment. Here it is. And then after that we can create the Python virtual environment by running this command. And then after that, we need to activate the Python virtual environment by executing, oops, I made an error, by executing this command. And that's it. Now you can see that Python virtual environment is active. The next step is to install the Pytorch. To install Pytorch, go back to Google and search for Pytorch install locally. Then go to this website, and then over here, use this selection table to generate the installation command. So let's go with stable, Linux, pip, Python. Let's go with this CUDA version, and here you go. And this installation command will be generated. Simply copy this command and run it. And this is the only and the proper way of installing Pytorch. If you just type pip3 install torch blah 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 or something like that, you will get most likely an error and you will not be able to run this code. Always install Pytorch by using this approach. Okay, so let's wait for a while. It's going to take a while to install Pytorch since you're downloading around, I think, 3 or 4 gigabytes. Next, we will need to install several additional libraries. And let's see what are these libraries. Namely, if you go to the repository of this program, and if you look inside of this code, you will see several things. First of all, you can see Torch over here that's being imported. We have resolved this issue. We installed Pytorch. Good. How about transformers? Well, in order to use or to write this code and to execute it, you need to install transformers. So let's install transformers. You simply need to type pip install, and then you need to type this. Okay. However, in addition to transformers, we also need 2 libraries. We need the Hugging Face library. That is, we need this library. You need to run this command, and you also need accelerate. Why do you need accelerate? Well, I noticed while installing the Windows version of this software that somehow without accelerate it will not work. The accelerate is used actually to run this program and to somehow offload the memory. I'm not 100% sure how it works. However, after this video, I'm going to look it up. Okay, and that should be it. Next, let's start or let's create a test code. In my case, I'm going to use Visual Studio Code, and I will run it like this. If you don't have a Visual Studio Code on your system, don't worry, I created a separate video tutorial on how to install Visual Studio Code, and a link will be given in the description below this video. Okay, click on File, New File, and let's call the file test.py. Click, save the file in the workspace folder, and that's it. Now what we need to do, we need to go to this website, and over here let's copy this code. Remember to copy everything by clicking here, then go here, paste the code, and here it is. And let's analyze and let's see what this code will do. First of all, here we are importing the necessary libraries. Then we are specifying the address of the remote GitHub repository. Here it is, this part over here. Then we are specifying several arguments. We are specifying data type, device map. Auto means that we are automatically loading this with either CUDA or CPU support. That is, Pytorch will automatically figure out if Pytorch support with CUDA is installed, and if CUDA is installed. If it is, then we are going to use CUDA and GPU. Here we are creating a tokenizer. Then we are doing several additional things. We are creating a pipeline. We are specifying the default parameters over here, which are suggested by the people who created this repository. Then we are specifying thinking on, which will kind of increase the computation time. However, it will produce better results. And over here, we simply ask the question. So let's see what do we have over here. Our role is user, content, and here it is. We want to basically solve this problem. That is, we want to solve a relatively simple math equation. Let me undo this such that everything is in a single line. Let's save this and let's see what will happen. First time you run this code, all the files from this remote repository, the files are given over here, will be downloaded. And this will be done only once. That is the first time you run the code. The next time you run the code, the model parameters and safe tensor weights and other things will be automatically loaded from your local disk. So let's run this code. To do that, press and hold Ctrl Shift then P, search for Python, select interpreter, here it is. Then make sure that you select the correct Python interpreter. Now, here you can see that I have billions of things over here, right? There are billions of things here. So where is my environment? Here it is, right? Make sure that you select this environment and click here, and this will run the model. And here you need to be patient. Actually, there might be an issue over here. Let me do Control C. Since I didn't run the correct environment, I will going to repeat this. Control Shift P, Python select interpreter, and here it is. Should be this one. Let me run it again. Let me see what will happen. Okay, now it should be fine. Okay, let's see what will happen. Now we are downloading the files, right? We are downloading over here several things from the remote repository. Let's see what we need to download. We need to download these 4 files as well as these other files. However, these files are the biggest one. Consequently, it's going to take a while to download everything, maybe even like maybe 5 minutes or something like that. Consequently, be patient. And over here, after some time, everything will be downloaded and the model will be executed. So let's see what's happening. Here you can see device set to use CUDA 0. This means that we are using the GPU. So let's see. Usually your first GPU starts from 0, and when you see 0, this means that you're using GPU. Let's see how long will it take to execute this model. Let's see. And here it is. Here it is. Here's the solution. Of course, the solution is relatively straightforward. You need to factorize, then you see that one 0 is x0, another 0 is obtained by solving this equation over here, and that's it. Simple as that. Okay, that's all for today. I hope that you liked this video. If you like the videos I'm creating, please press the like and subscribe buttons and see you in the next video tutorial.